Okay, so today is day 6 of the Leetcode Saturday coding challenge. Today's question is group anagrams. We have an input array of strings. We need to group the anagrams together. The input we have here is an array of 6 strings. The output is an array of arrays, where in each array the strings are basically a permutation of each other. That's what an anagram means. We just shuffle the characters around. We can transform any one of the string into any others within if they are within the same array, within the same group. Some notes here: all inputs will be in lowercase, so I guess we're dealing with English lowercase letters only. That's just 26 of those letters. The other note here is the order of the output doesn't matter. So we don't need to sort individuals. We don't need to sort the strings within the arrays, and the order these arrays be nested within the bigger array doesn't matter. So that's just making our life easier. So yeah, basically the question is asking us to group things. A very natural way of doing this is to create a hash map, with the key being some calculatable key value and the result being an array of things. So we just use that hash function on each of the strings and use the result as the key for us to insert the string into the buckets. After that, we get the key value pairs. We just extract all the values from the map, hash map. Then that's basically our return value. The question is how to design this hash function. The function needs to do just one thing, right? For the anagrams, the output of the hash function needs to be the same. So one very easy such hash function is to return the sorted version of the input string. So like eat, t, we will return aet for all three cases. And just to sort the characters within the string, we'll get AET for all of these inputs. So that AET is going to be the key to the hash map, and tells us to insert these 3 different strings into that particular bucket. And so for that, we will need to sort each individual input string to get the key. If the average length for all these strings is k, that's k log k for sorting, and we have n of such strings, the time complexity for use that hash function is going to be n multiplied by k log k. So it's good enough, but there is a better way of creating such a hash function. Basically, if we want to determine whether the 2 things are a permutation of each other, the 2 strings are permutation of each other, all we need to do is to do the frequency count of the individual characters, the individual letters. So we have 1A, 1E, 1T for EAT. For T, we also have 1T, 1E, 1A. So the frequency count, that's just to go through this string once to get that the frequency count is going to be also just that frequency count as an output is a valid key for hashed key for our purpose. So that would reduce the time complexity of the whole algorithm to be from n k log k if we are sorting down to m multiplied by k, and that's pretty much the strategy. So I'm gonna start coding. So what we're gonna do is to basically initializing a hash map, which is this string to a vector of strings. We call it group by, groups or group by, doesn't matter. And the result, the output is going to be a vector of strings. We call it anagrams. So what we need to do is to fill this hash map in the first step. It's going to be a two-stage operation. One is to creating this, generate this group by. The second thing is to extract all the values from this hash map. So we go through all the strings. And what we're going to do is to pass the string into some yet need to be defined hash function, and that's the key. And what we need to do is push the strings into that bucket. So that's the first step. The second step is to extract the values from the hash map into the anagrams. And in the end, we just return the anagrams. So as a very quick, easy such hash function will be return a string, which is the sorted version of the input string. So this will lead to n k log k. So yeah, let's see if this works or not. Oh, okay. I have a typo. So yeah, this one works. But the better way is to do just create a better hash function. Will be just to return a frequency count. So that we will do. The input is still the string. The output is also going to be a string, indicating the representation of the key. What we need to do is to have a vector of size 26, the lowercase English letters, which initially to be all 0 in the beginning. For each of the characters in the string, we increment the frequency count for that character in this table. And then we need to basically create a string representation of this frequency count to use as the key in the hash map. So for that, we're gonna initializing a string stream. Call it the frequency string representation of this thing. And what we need to do is copy each individual, just converting the count, integer count, into strings, and pipe them into this frequency stream. So the elements in this frequency tables are integers. We need to cast them into and cast them into strings, and also concatenating with some kind of indicator to indicate that the count is for this particular location, then to distinguish different locations. And yeah, so this looks like in the end we just return the string version of this thing. So this is another possible implementation of the hash function. Yeah, so that's the question for today. For the second implementation of the hash function, that reduce the time complexity for this code done to m multiplied by k. But actually, you can see here for the frequency it's one pass. The copy is going to be another pass. So it's actually 2nk. So it depends on the value of k. Nk log k actually might be smaller than k. Let's say that the input is all length 3 characters. So this might be actually slower compared to just sorting. It depends on the input size. So that's the analysis for and code for the question today.